Okay, we are in the branch of mechanics called kinematics, the study of motion without regards to the forces causing motion. And we have three main categories of parameters. The first is position, and we have displacement, straight line distance between 2 points, and that's a vector, and distance, total change in position, and that's a scalar. And we have our equation delta S equals final position minus initial position. We don't have an equation for distance, we just measure that total change in position. The units are any units of length. So for example, e.g. meters, yards, feet, seconds. Oh, excuse me, not seconds. Yeah, it's end of the day for me. Okay. The second parameter is velocity, which is the time rate of change of displacement. And our equation is V equals displacement over time, or SF minus SI, final position minus initial position, divided by final time minus initial time. And the units are any units of length over any units of time. So for example, e.g. meters per second, or miles per hour, kilometers per hour, what have you. The closely associated term with velocity is speed. And speed in a physics class would be the magnitude of the velocity vector. This is a vector, this is a scalar. And speed is also distance over time. Same units, it's just a scalar, not a vector. And the third parameter is acceleration. And that is the time rate of change of acceleration. Oh, excuse me, of velocity. Oh, I'm really tongue-tied today. Acceleration equals change in velocity over change in time, or final velocity minus initial velocity divided by the change in time. Units are any units of velocity over any units of time. For example, meters per second, which is the same as meters per second squared. All right, so these are our three main kinematic parameters, and we need to know these, we need to understand them. Position is easy to understand. It's just change in location in space, and we can set up our Cartesian coordinate system, our X, Y, and Z. So well, usually I do Y and I do Z down here, and we can track where that object is going, and we can track the change in position. Velocity is also easy to understand because we deal with speed all the time, and that we have a speedometer on our car, and we know what 35 miles per hour feels like, or 50 miles per hour. And we know that, 50 miles per hour is changing, in this case, distance faster than over some time period than 25 miles per hour. So speed is an easy thing to understand as well. The tough one to understand is really acceleration, because now we're talking about how fast velocity is changing. So really, how fast velocity is changing. And we need to use terms like speeding up and slowing down. And then we also need to use terms like, so this is one category of terms, sorry about that, speeding up or slowing down. And we also need to know what direction movement is in. So we're either speeding up or slowing down if we're dealing with something going forward or backwards. We would say speeding up moving forward, or we would say slowing down moving backwards, or speeding up moving backwards, or slowing down moving forwards, whatever that combination is. Direction of movement and whether or not velocity is speeding up or slowing down. Now there is a third one, and the velocity could be constant. And if velocity is constant, because there's no rate of change of velocity, that numerator is zero, that means acceleration equals 0 meters per second squared. Okay? All right, so what I want to do is explore this a little bit more in words and description, and dealing with something that we deal with every day, and that is our car speedometer. or if you're a bike rider, your bike speedometer. So if we go into a car, although not everyone has this type of speedometer anymore, but in my day growing up, I would have a speedometer in my car that would look something like this, where 0 miles per hour is down here, maybe here is 50 miles per hour, and maybe over here is 100 miles per hour. And then I'd have a needle that would sit on the gauge like this, and then I'd press on the gas pedal, and the needle would move in this direction. Gas pedal. I'd be speeding up. Well, I guess I need to also say that I'm putting the car into drive, shift into the right gear. And then if I speed up, I can also push on the gas pedal. I can also push on the brake pedal, and I can bring my speedometer back to 0. And so brake. So now I speed up by pushing on the gas pedal. I slow down while pushing on the brake. But that's specific when I'm in the drive gear. Now, what happens if I put my car in reverse and I have this type of speedometer? If I push on the gas pedal, which way does this needle go? Well, you'd have to check your car, but and if you have a digital speedometer, I don't know if does it have negative velocities when you go in reverse? I'm not sure, but check. Just make sure to look behind you and don't run into anything behind you if you are doing this. All right, so but I want to create a different type of speedometer. Again, this is the type of speedometer that would exist in my Chevy Malibu, my Renault Alliance, or my Subaru Brat. I'm going to create a different speedometer though, same shape, almost. And I'm going to put 0 here in the middle, okay? And then I'm going to put negative speeds here, and I'm going to put positive speeds here. In essence, what this negative speed means is I'm in the reverse gear. And this positive speed means I'm in the drive gear. So now I need to tell you two things. I need to tell you which gear I'm going to be in, and then which pedal I'm going to be pressing on. And interestingly, both of those pedals are accelerator pedals. That, in this case, is accelerating, and velocity is speeding up while moving forward. And this is accelerating and velocity is slowing down while moving forward. So they're both accelerator pedals. All right, now let's say we start at 0 here and I shift into drive and I press on the gas pedal. Well, then my speedometer needle will move in this direction, gas pedal. All right, now I'm still in drive. I'm not going to grind my gears. I'm not going to do anything weird. And then I'm going to push on the brake. And what happens? My speedometer goes back and I'm going to go to a stop position. So it goes all the way back to 0. So I'm going to push on the brake. So now I have a situation where I'm speeding up and then another situation where I'm slowing down while moving forward because I'm in the drive gear. All right, so I'm gonna put another little arrow here. I'm gonna say speeding up, moving forward. And I'm gonna do a little arrow here. I'm gonna say this is slowing down, but I'm still moving forward. All right. Okay, so now I'm going to, well, let's do this. I'm gonna put a little plot down here because I like to plot things. And I'm gonna do this. I'm gonna draw it like this. I'm gonna put velocity here. And even though I'm calling this a speedometer, it's really, we're talking about velocity. And I'm gonna put positive velocities up here, negative velocities here, and 0 velocity here. And this would be, axis would be time. And so now let's just envision what's happening here. I'm at 0 miles per hour. I push on the gas pedal and the velocity gets greater, the speed gets greater. So I'm gonna have some type of line. I'm just gonna draw it like this. It's not a straight line, but it's close enough. All right, this corresponds to this section right here. I'm speeding up while moving in the positive direction. Remember, the direction of the acceleration vector does not tell us which way we're moving. The direction of the velocity vector does tell us which way we're moving. And in essence, these positive velocities are drive gear, and these negative velocities are reverse gear. Okay? So positive velocities, I'm in drive. I push on the gas pedal, and I speed up while moving forward. Now, at some point, I push on the brake pedal, and I'm at that velocity, and I start to slow down. So I'm going to put brake. So speeding up, moving in the forward direction, slowing down, velocities are getting less, while moving in the forward direction. All right. All right, that's part of the situation. Now I'm going to do this. And now let's say I'm at that stop position and I shift into reverse gear and I push on the gas pedal. What happens to this needle? If I'm in reverse gear and on my speedometer here, it's going to go like this, getting faster and faster and faster, going backwards. All right, so I'm going to do an arrow this way. And I'm also going to put gas. Okay. And then I've sped up, and now I want to slow down. And my speedometer goes back to 0. And which pedal am I depressing? I'm going to press the brake pedal. Ah, okay. Well, velocity's changing again, which means there's acceleration here, and there's acceleration here. I'm speeding up, moving in the reverse direction. I'm slowing down while moving in the reverse direction. So let's write that down over here. I'm speeding up, moving backwards. And that's this region right here, this situation. And then I'm slowing down, moving backwards in this region here. Speeding up, moving backwards, pressing on the gas pedal, getting faster and faster and faster going backwards. I hit the brake, I get slower and slower and slower, but I'm still moving backwards. What's that look like over here? This is my drive situation here. And now I'm going to be in reverse. So I'll continue this out. Well, I'm starting at 0 and I'm getting faster going backwards. Remember, all the negative velocities are telling us we're in reverse gear. So now I'm going to have a situation that looks like this. And which pedal am I stepping on? I'm stepping on the gas pedal. And so now I'm going from 0 miles per hour to -5, -10, maybe -20 miles per hour. These are all negative velocities. These are all indicative of being in reverse gear or moving backwards. I'm stepping on the gas pedal. Okay, that's this situation right here. Whoops, this situation right here. All right, so now I step on the brake pedal and I'm in reverse gear and the speedometer goes back to 0. So now I get something like this. And I'm going to put brake here. What's happening kinematically? I'm slowing down while moving in the negative direction. I'm slowing down in the reverse gear. I'm slowing down, moving backwards. I'm going from -20. All right, if I do this, I can draw a line over like this. I'm going from maybe -20 to maybe -15 to maybe -10, -5, 0. I'm going from -20, -15, maybe -5, ultimately getting to 0. The magnitudes of velocity are getting less, 15, 10, or 20, 15, 10, 5, what have you. The negative sign of that velocity is simply telling me I'm moving in reverse. Okay? All right, so now let's tie this in with acceleration. What is happening with acceleration here? What we want to be able to do at this stage is identify whether or not the direction of the acceleration vector is positive or negative. All right. The direction of the acceleration vector does not tell us the direction of motion. The direction of motion is told by the direction of the velocity vector. So down here, I'm going to write the direction of acceleration. And what do we have here? Well, if we go back to looking at our slopes, then if we have a positive slope of velocity versus time, we have a positive acceleration. If we have a negative slope, we have a negative acceleration. So I'm going to put that down here. I'm going to put positive A, negative A. The direction of the acceleration vector does not tell us which way we're moving because we're slowing down, moving in the drive gear, moving in the positive direction, moving forward. But that is a negative acceleration. Now, a lot of times this part makes sense because, oh, I've got positive acceleration. I stepped on the gas pedal. That gives me positive acceleration. Oh, I step on the gas pedal. I step on the brake pedal. That gives me negative acceleration. Don't fall into that trap. It's a terrible trap and it's hard to get out of. Direction of acceleration does not tell us which gear we are in. Negative acceleration, but we're in the drive gear, positive velocities. We're in this region right here. Positive acceleration, still in this region, still in the drive gear, but because velocities are positive, not because the acceleration is positive. Let's look at that right over in this region here. What direction is this slope? That's a negative slope. Therefore, what direction is acceleration? It's negative. Negative acceleration, but what's happening? We said that is speeding up while moving in the reverse direction, while moving backwards. And that's a negative acceleration. What direction is this slope? That's positive acceleration. What's happening kinematically? We're slowing down while moving in reverse gear. So here we have a situation where I have a positive acceleration that's speeding up, moving forward, and I have a positive acceleration, meaning slowing down while moving backwards. The direction of the acceleration vector does not tell us the direction of motion. That is critical to understanding acceleration. What does the direction of acceleration tell us? Well, it tells us the direction of the velocity versus time plot slope. This is a positive slope. This is a positive slope. It doesn't matter where zero is. I could put zero anywhere. The direction of those slopes is not going to change. That's a positive slope. That's a negative slope. That's a negative slope. That's a positive slope. Direction of acceleration vector, when we do one dimension at a time, is going to tell us the direction of the slope of the velocity versus time plot. Where zero is simply tells us which direction we're moving in. So if we're above this zero, anywhere in this region, we're in the drive gear. If we're below zero, we're in the reverse gear. We're moving backwards. So the positive acceleration here means the velocity versus time slope is positive, and I'm slowing down. Magnitudes of velocity are getting less. Negative 20, negative 15, negative 10, negative 5, ultimately 0. Velocities are getting less. You can think of that as the absolute value. 20, 15, 10, 5, that's getting less. I'm going from 20 miles per hour, 15, 10, 5, 0. I'm slowing down while moving in the reverse gear. I'm speeding up while moving in the reverse gear. And the direction of acceleration simply tells me the direction of this slope in velocity versus time. All right, so key phrases: direction of acceleration does not tell us direction of motion. And to get the direction of acceleration vector, we simply look at the slope of the velocity versus time plot. And we don't concern ourselves where zero is. A negative slope is a negative slope. Positive slope is a positive slope. Doesn't matter where zero is. All right, This is so important to understand acceleration, and it's one of the hardest parts of understanding acceleration. But I'll give you a little bit of insight where we're going. Is we are going towards kinetics, and we want to understand Newton's second law of motion. And to understand this equation, we need to understand acceleration. We need to understand what it means, rate of change of velocity, and we need to understand it's a vector, and the direction of the vector is simply telling us the slope of the velocity versus time plot. Okay, that's where we're going. Thanks, everyone. I hope this was helpful, and I will scan these notes and put them up on Canvas. Thank you.